Hi everybody, welcome to the last lesson of Unit 6. We're going to continue talking about word problems with linear functions. So your aim is that you can use the form of y equals mx plus b to model real-world situations, in addition to describing what the numbers in that equation means, like in terms of real life. Although it can be challenging, it's critically important that students who exit Algebra 1 have a good ability to deal with linear relationships. In this lesson, we get more practice modeling linear phenomenon. So let's take a look at example 1, a linear situation. A warehouse is keeping track of its inventory of cardboard boxes. Okay, so it's a building full of boxes. At the beginning of the month, they had a supply of 1,275 boxes left. They use boxes at a rate of 75 per day. So I'm underlining that important information. So letter A says, how many boxes are left after 10 days? Show the calculation that leads to your answer. So I start with 1,275 boxes, and then after 10 days, how many have I lost? Well, if I'm losing 75 per day, then that's 75 times 10, because it's 10 days. So I start with 1,275, and then I subtract how many I use. So now all I have to do is solve this. So 1,275 minus 75 times 10 is 750. So after 10 days, they've got 525 boxes left. Okay. Letter B. Which of the following linear equations correctly models the number of boxes left after D days? So basically what this question is saying, okay, how can we take what we did here and turn it into an equation? Well, if we let n be the number of boxes, we started off with 1,275, and this was the constant, this 75 per day, that was that rate that we had, so it's minus 75 per however many days we have, because this is where we, plugged in that 10, right? So this is the formula that goes with B, and that matches letter number 3. Okay? All right. C. One thing also to keep in mind that's important here is that, this word here, using boxes, is the kind of same thing as they're losing boxes, and that's why this is negative, because they're losing boxes. So that's one way to check your work. A negative sign means decreasing or losing. C. If the warehouse needs to order more boxes when their supply reaches 150, how many days can they wait? So this warehouse is saying, look, when we get down to 150 boxes, that's when we have to order more. So we're basically saying, let's figure out how many days that's going to take. So now I'm going to set my equation equal to 150 and try and figure out how many days that takes, minus 75D. Okay, so now I'm going to solve for D by subtracting this 1,275 over. 150 minus 1,275 is negative 1,125 equals negative 75D. Divide both sides by negative 75. They cancel out and we get that D equals 15. So 15 days, they can wait 15 days before ordering more. Okay? Letter D. If after 5 days they start using boxes at a rate of 90 per day, how many days will it take before they're out of boxes? So now all of a sudden, we have to figure out using this 90 per day. But there's kind of a trick here, and it's kind of sneaky. Do you see how they have this first part that says if after 5 days they start using boxes? So what's that saying is for the first 5 days, they still use the same rate. So we're still going to use our original 1,275 minus 75, and then plug in the 5 days to figure out how many we'd have. So we get 1,275, 75 times 5. Okay, so hold on, I messed up with my pen. So if I plug 5 days into here, then I'm gonna simplify and get 1,275 minus 375, which is gonna give me 900 boxes after 5 days. That's important because if the first 5 days we still have to use the 75 rate. That's why I did that first part in blue. Then all of a sudden, I'm gonna pick red to show this. Then we have this new rate. That's a new rate of 90 per day. So now I can say, all right, now that I've just got 90 boxes per day, I can say 90, how many days will it take me to use up 900 boxes? So I've got this new equation for this new rate. So now all I have to do is solve for D, divide both sides by 90, and I get that D equals 10. That's not my final answer because it originally took me 5 days with my original plus the 10 days left with the 900, so 15 total days when I run out of boxes. That was a tricky problem because you've got two rates in one problem. So you've got to be really careful and make your two separate equations for that example. Okay? Alright, exercise 2. We want to feel very comfortable with quickly and accurately depicting linear models. Keep in mind the two most important aspects of any linear model are its rate of change, which is a slope, and its starting value, which is your y-intercept. Okay? In fact, what I'm going to do is at the top of the page, I'm going to write that. Remember, y equals mx plus b, where m is your slope, b is your y-intercept, but in terms of story problems, b is your starting value. Okay, your y-intercept doesn't help you here because we're not graphing these really. We're just talking about them in terms of starting and rate. So your y-intercept for b isn't the best way to describe b. It's better to describe b as being your starting place. So let's look at exercise 2. The cost C in dollars of running a factory that produces widgets can be modeled using this linear function C of W equals 1.525W plus 2,175. So we've got a factory that's producing widgets and we're finding out the cost. So letter A says, how do you interpret the fact that C of 100 equals 2,300? So I'm going to remember that C here is cost and W is widgets. And remembering that this right here means that widgets is on the inside, right? C stands for cost and W stands for widgets. So when I have this statement right here, this 100 stands for widgets and this 2,300 stands for cost. So when this question is asking me to interpret what this equation means, they want something in English that says, what does it mean? Well, it means that if I want to make um, 100 widgets, it will cost $2,300. That's what that means. If I make 100 widgets, it's going to cost $2,300. Okay? Letter B, give a physical interpretation for the two parameters in this equation, 1.25 and 2,175. So again, this physical interpretation means, what does this mean? Yes, 125 is the rate, and this is your start. That's not what this question's asking for. It's asking for, what does that mean? So our rate is 1.25, but what this means is that this is how much it costs to produce one widget. It costs $1.25 per widget to make. Okay? If I want to make 2 widgets, it's going to cost me $2.50. You know, I'm going to multiply that 125 by how many widgets I have. So 1.25, $1.25, it's going to cost me $1.25 to produce one widget. The other part of this, the 2,000, oops, my eraser, hold on. The other part, the 2,175, yes, it's my starting value, but more importantly, and this is something you think about when you think about business. So you kind of think about Miss Pierre's class, if any of you are taking business with her. This 2,175 is your startup cost. My eraser's being weird. It's like your startup cost, meaning it will cost $2,175 even if no widgets are made. Think of this in terms of how much it costs to heat the factory, turn on the lights, the staffing, all of that thing. There's a cost there, even if you don't make anything. It costs you money just to turn the lights on in the place. So that's what that 2,175 comes from. It's your startup cost, even if you don't make anything. So that's what this question is asking. It's really important when you see Common Core questions like this that you're trying to understand that they want more than just you saying rate, slope, starting point, y-intercept. They want meaning. That's what this word interpretation means. They want meaning. Okay? All right. Exercise 3, I believe, is just one big problem. No, we've got 2 more problems left. Okay, so exercise 3. Biologists estimate the number of deer in Rhode Island in 2003 was 1,028. In the year 2008, it had grown to 1,488. Biologists would like to model the deer population as a function of years since 2000. Okay, so we've got important information here that I'm going to underline. So I have this information that in 2003, there was 1,028 deer, and then in 2008, there were 1,488. And then this is important too, this since 2000, because what this is saying that, you know, you're counting the years starting at 2000. So the year 2000 is like saying the number 0. The year 2001 is like saying the number 1. So it's a little bit different than just plugging in these years. You actually have to think about what they mean 0, 1, 2, 3, 4, and 5. So letter A says represent the information we've been told as 2 coordinate points. So the first coordinate point, you'd originally think, and I'm going to write this but don't copy this down, normally you'd think, oh, 2003, 1028, right? Because that's the 2 pieces of information. But the part that I circled and I just talked about, that's not correct. The year 2003 actually gets converted into the number 3. So my first point isn't 2003, it's just the number 3, comma, 1028. My second point is going to be not 2008, but the number 8, comma, 1488. So these are my 2 coordinates where this is years and this is my deer population, okay? Letter B, calculate the change in P over the change in T from 2003 to 2008. So this is just saying, hey, find the rate of change. We know how to do this. We just subtract our values. So let's subtract the numbers on top. So that would be 1,488 minus 1,028 over 8 minus 3. We've been done this a lot in this unit. Now we calculate 1488 minus 1028 is 460. This question wants me to use units, so I know that it's deer, and then 8 minus 3 is 5. So 460 over 5, deer every 5 years. That can be reduced to 92 deer per year. So my rate is, they're increasing at a rate of 92 deer every year. Okay? Or at least that's what this model is predicting, that there's going to be 92 deer every year based on these 2 pieces of information. So letter C, give a physical interpretation of the value you found in part B. Well, I just kind of answered that actually. That 92 deer per year is saying that in Rhode Island, the deer population is increasing by 92 a year. Right? That's my interpretation of meaning behind my rate. Letter D, determine a linear relationship between the deer population and the years since 2000. So this is us trying, a linear relationship means, hey, make an equation. That's what that's saying. We already know the rate. We know that the M equals 92, right? We found that from the top. But we don't know what B is. This is one of those problems where we don't know what B is. We do know P and T because we have these 2 points here. And I'm just going to use the 3, 128, right? P is 3, T is 128. So if I have P equals mt plus b in my form. The population is going to be, oh, sorry. The population is not going to be 3. I'm mess these up. This is, sorry, t comma p. Okay. So the population is going to be 1028. My rate was 92. T in 3 years. And then I'm trying to find my b value that I don't know. So we've done this before in this unit where we've plugged in x, y, and m to try and find our y-intercept. That's just what we're doing right now. 92 times 3 is 276. Subtract the 276 on both sides. They cancel out, and you get that b equals 752. And then to write your equation, we're just going to plug everything in. P equals our rate of 92, t plus 752. That's our equation after we found b. Okay? Letter E. How many deer does the model predict were in Rhode Island in the year 2000? This is a very fancy way of saying, hey, in the year 2000, that's like saying t equals 0. So this question is saying, well, how many deer? So what does p equal if t equals 0? So we just have to plug those numbers in and get our answer. So I have my equation, p equals 92t plus 752. I don't know what p is, so I'm going to leave it a variable, but I know that t is 0, so I'm going to plug it in for t. Now I solved. 92 times 0 is 0, so I get that the population was 752. What does this represent about the linear function? This is saying that this value of the function is the y-intercept and the starting population of deer. Okay? And finally, letter F, how many deer does the model predict for Rhode Island now? Okay, well, the year now is the year 2016. So we're looking for this model in terms of t equaling 16. So now we plug in 92 times 16 plus 752. That means that p is going to be 1,472 plus 752, and that makes p equal to p equals 2,224 deer in 2016. Okay? So that's us predicting our Rhode Island now. Okay? Alright, that finally onto our last linear problem. Actually, this problem is not linear, that's the whole point of this problem. So exercise 4 is our last word problem. Let's read this carefully. Water is draining out of a bathtub such that the volume still left in gallons is shown as a function of the number of minutes. So we're saying after so many minutes, how many gallons are left in the bathtub? And I'm going to underline this part right here, this draining out, because this is a decreasing relationship, which is a big clue that my slope or rate is negative. Okay, that's that big clue right there. All right. Letter A says calculate the average rate of change of G over the interval 0 to 2. We have done this so many times as a as a class, finding the rate of change. So I want my change in gallons over my change in minutes. Remember, I like to label this sometimes as X and Y to help me remember that I'm going to subtract those values over those top values. And these are like my little X's. So I'm going to have 2 minus 0 on bottom, and I'm going to find f of 0 and f of 2. So at 0, the answer is 62. So I know I've got 62 here. And at f of 2, I have 28. So I've got 28 minus 62 over 2 minus 0. 28 minus 62 gives me negative 32. 2 minus 0 gives me 2, which simplifies to negative 17. It makes sense that it's negative because I underlined that decreasing thing up there. So that answer makes sense. And I'm going to put rates as gallons per minute. So from 0 to 2 seconds, it's decreasing it by 17 gallons a minute. All right, letter B now says calculate the rate of change of g over the interval 2 to 4. So I'm going to now calculate from 2 to 4. So same formula, change in g over the change in m. So on the bottom now, I've got 4 minus 2, and I'm going to find I'm going to find at f of 2, so I get 12. Oh, sorry, let's back up. I have to find y when m is 4 and 2. So at 4, it's 12. So I'm going to put the 12 above the 4. And at 2, again, it's the same number, 28. Now I'm going to subtract. 12 minus 28 gives me negative 16. 4 minus 2 gives me 2. And now I get negative 8 gallons per minute. Well, that's very strange because so far in what we've learned, that if something is linear, it should have the same rate. So when we look at question letter C, this question is saying, why can we say the relationship between m and g is not linear? What is the one thing that's true about a linear function? In a linear function, the rate is always constant, meaning the same. Always. This can't be linear because the rates are different. Right? Negative 17 does not equal negative 8. They're not the same. So this right here is not linear. This is something else that we're going to talk about later. So it's really important to recognize that if you have an interval in the same function looking at two different intervals and they're not the same, they're not linear, they're not constant. Okay? I know word problems are tough, and we're going to start using that problem-solving template to try and get through it. Again, you should ask me questions on the fluency. If there's a student in this class that can do all of the fluency by themselves, no answer key, I will be super impressed. So all of you should be coming to me, Ms. Samru, Ms. Vasquez, for help on 6.5 and 6.6 fluency before you take mastery. Okay? Good luck finishing up Unit 6.